surroundings. And what I do is there's one simulation that brings it to steady state, then there's a 10-meter base level drop, and then it returns to its original conditions. So if we run this simulation, okay, we get to more or less steady state, and then we introduce that perturbation, and you kind of see the change sort of pulse through the landscape following the rivers. And we can plot the change in mean elevation over time by X Nick 44. Running a different visualization script. So this is plotting mean elevation in meters versus time. So we have our first condition, which just brings us to steady state, then a 10-meter sharp increase in elevation, and then the gradual decrease back to our steady state condition. So that's one way you can sort of track the response rate and its the influence that damage zones may have on that rate.
It's also a neat way of thinking about like an earthquake outfall or something.
Yeah, exactly. Yeah. So after you run the simulation, you can, there's another script in here called the KME plot that just stands for kinematic mean elevation plot. And by putting in KME plot, give the name of the run you just did, number of steps, and as an output arguments, I just have the time and elevation or output, and that produces this image here. Yeah, so that's a slope area plot. So KSA plots, and that takes the same input arguments. So X Nick 4. So a plot of slope versus area here. Slope in the X, area in the Y, and this is the result. The reason why there's more than one profile there is because of the different erodibilities for the different rock units. They'll have a different slope area, different steady state slope area profile. Okay, so I have a question for some of you who you didn't have the damage zones up here, which is pretty much all of you. Could you open up the folder titled Fault Erosion in the CHILD folder and take a look at faults_erosion.in? And within that file, could you search for opt read lay file and see if it's equal to 1 or not?
It is.
It is? Okay. All right, it's something else then. Unfortunate.
What's the difference between an opt-read layer?
So this allows you to, if you're importing a points file instead of a previous run, this allows you to import a layer file for the points file as opposed to a layer file for the previous run. So it separates the two. But because I'm using a points file system, I have to use this method. opt underscore read underscore lay file. So it's, I'll show you what it looks like here. So it's, yeah, we're looking for this right here, opt read lay file, just to check and see if it's actually reading the layer file that it produces. In the input file, opt read lay file should be 1 if it's reading the layer data. So we make a layer file from the CHILD script, and it should read it in, but there's something going on. 12, you say?
Yeah.
Is it opt read lay file, or is that opt?
No, that's opt read input.
Yeah, that should be 12. That should be line 57.
57, so Y is okay?
Yeah. So it's something else is happening.
And that's what it should be.
Okay, so that's to read or freeze.
Sorry?
What does the 1 represent in that option?
That means that it should be reading a layer file that we produce from CHILD from the fault information. Yeah. So it should be imposing that fault damage zone in the model domain, but for some reason it's deciding not to. Unfortunately.
My late damage model finished running.
Did it produce a damage zone, or
Yeah.
did it? Ooh, can I see? Well, that's a lot of.
No, I've seen it.
I'm
Okay, so there's a strike slip.
Window than a door or something.
Oh my God!
So how did you get it
How
to
d-
work?
I mean, I just ran his model run. It just took 25 minutes to do it.
So actually,
If
the one that I
this,
started running when I got impatient, I think was this one, and I didn't
Yeah,
get
because
as far.
this one is
Yeah.
it's 400 time steps.
Yeah.
What's the
Okay.
difference?
so
That's even more bizarre.
The
So I
late
think
damage.
Mark found that if there is a motion, there will be damage as well. But if there's no slip, then there's no damage for some reason. So it's something. It's just a switch in the MATLAB code that.
Anticipating reality, really, isn't it?
I guess so. Yeah.
Right.
like,
If you
no,
don't
you've run
slip,
this
if
wrong.
you don't slip, you don't.
There's no
lose the
damage.
zone.
Yeah. So it's like shame on you, Sam. You should have thought about
Sam,
that.
turn around. Those reviewers are right after all.
They were.
I don't mean that. Okay.
Well, that's heartening.
Well, we do have a problem with we couldn't get the Pluton one to work or anything.
No.
I don't
Okay.
know.
I think it's the same issue where there's no change in erodibility if there's no slip. That's what it seems. So I'm going to have to track that
But
down.
we couldn't even get the non-damaged Pluton to work.
It's still
Oh, right.
it's still
'cause
heterogeneous.
Yeah, it's
so,
still heterogeneous.
yeah.
Actually, yeah, because
Anytime
I,
there was
I
a-
saw the
yeah.
flash between when the second set of conditions kicks in, but it doesn't do anything different, and it doesn't show the